Welcome, Math Humans. We're going to do 9.2 today. We're going to be talking about arithmetic sequences and series. Our objectives are, that we're going to define an arithmetic sequence. Then we're going to write a rule and find the nth term or terms of a sequence. And then we're going to find partial sums of an arithmetic sequence. All right, so I've written a couple of our definitions out ahead of time. In an arithmetic sequence, the same value is added or subtracted to every term in the sequence. So if you think about it, it's very similar to slope, okay? So each one of these terms, remember that it's not a connected line for a sequence. Each term is its own individual entity. But notice that the difference between each of those terms is the same. So it is similar to slope. It's called the common difference. We find the common difference by doing new divided by old. And by new divided by old, if I have a sub 1, a sub 2, a sub 3, etc., this is considered the new, this is considered the old. So it's new minus old, and that helps you find the common difference. Or I could, if I had terms that were further out, I could have done a sub 7 minus a sub 6. So there are two types of formulas that we will use in our sequences. One is called an explicit formula. An explicit formula is in terms of a number's position. So for example, a sub n, which means it's a general rule for a sequence, is equal to the first term of the sequence plus n minus 1 times d. Okay, so a sub 1 is the first term of the sequence. Remember, n is a term's position, and then d would be the common difference. And if you weren't told what the common difference is, you can find it by subtracting new minus old. Okay, so the other type of formula that's going to happen is a recursive. So that's the other type of formula that we can have for our sequences and series. But for right now, I'm not going to talk about this because we'll talk about it in other videos. So let's do our first example. So this is going to be example number 1, and it says find a formula for the nth term of the arithmetic sequence, it's a lot of words, whose common difference, I'm getting there, whose common difference is 3 and whose first term is 2. Okay, so I want to find a formula for the nth term of an arithmetic sequence whose common difference is 3 and whose first term is 2. So I'm going to use the formula a sub n is a sub 1 plus n minus 1 times d. And in this particular problem, they gave us all of the relevant information. So as I write, I'm just going to fill in what I know. They told us that the first term is 2. Here's my n minus 1. This is your variable for the equation. And it says that my common difference is 3. Now, so a couple of things about your book. I think it's okay to stop here. Because if you stop here, this lets me know that A, you use the correct formula, and B, you put all of your numbers in the correct places. The book would distribute, so the book would do a sub n is equal to 2 plus 3n minus 3, and so they would write a negative 1 plus 3n, and they would write that as your rule. Either is appropriate. I'm okay if you stop here. That just means that you might want to do a little bit more math just to check and see if you got it right. But I'm okay on a test if you stop here. Alrighty, so that was easy. A nice straightforward example to begin with. So for example number 2, it says that the fourth term of an arithmetic, and I have to tell you what type of sequence it is because eventually we will have geometric sequences as well. So the fourth term of an arithmetic sequence is 20, and the 13th term is 65, write the first 5 terms of the sequence. Well, before I can write the first 5 terms of the sequence, I need to write a rule, and then I'm going to use my grapher. Okay? So I write down my given information. It tells me that the 4th term is 20, so I write a sub 4 is equal to 20. And then it tells me that the 13th term is equal to 65. So if I want to find my common difference, because it's arithmetic, right? So it does the same process does not work for geometric, but in an arithmetic, and I spelled it wrong, sad day, I can do 65 minus 20 and divide it by 13 minus 4 is 9, and I get that my common difference is 5. So that actually makes finding my common difference pretty easy. So now I'm going to write my equation. So a sub n is equal to a sub 1 plus, and then here's my n minus 1 times 5. The thing that I don't know is a sub 1. So I'm going to choose this term, substitute in everything I know so that I can solve for a sub 1. So I know that a sub 4 is 20. I don't know a sub 1. I know that his n, was 4 minus 1 times 5. So this is a sub 1 plus 4 minus 1 is 3 times 5 is 15. So now I can solve for a sub 1. So a sub 1 is 20 minus 15, which is 5. So now I have everything that I need to write my official rule. So a sub n is going to equal 5 plus n minus 1 times 5. And I could substitute in n is 1, n is 2, n is 3, etc., and find the first 5 terms, or I can use my handy-dandy grapher. And I'm going to use my handy-dandy grapher. So the first thing that I need to do is put my calculator in sequence mode. Then I'm going to quit. I'm going to go to my y equals. The first line tells me which term of the sequence I'm starting on. I'm starting on the first term. So I'm going to enter 5 plus parentheses. Notice that the variable when I'm in sequence mode is n times 5. Okay? And then I can tell it what the first term is. It's 5. I don't have to because it's already in the equation, but I will just because we found it. So then I'm going to quit. And then I'm going to do second U, which is right by your 7. And I'm going to tell my calculator to do the first 5 terms. And there are the first 5 terms of my sequence. So when I report, I would say A of 1 to 5 is going to equal, remember in sequences we use the goofy little parentheses, and I would write 5, 10, 15, 20, and 25. And yes, you could have figured those numbers out without using your calculator, but I just want to make sure that you understand how to use your grapher in sequence mode because it saves you a ton of time. So the next thing that we want to talk about is that other formula that I mentioned, and it is a recursive formula. And this one is a little bit different because this particular formula is written in terms of the previous number. Okay, so a recursive formula is written in terms of the previous number. So the formula might be a sub n is equal to a sub n minus 1 plus d. And it's actually a very simple formula, but you need to notice the difference in the notation. This says a term is equal to n minus 1, so that's going to be the previous term, and then of course d is your common difference. Okay. All right. You do need to be careful. There's some additional notation. We would say n is greater than or equal to 2. Notice if I substitute a 2 in here, 2 minus 1 is 1. And so that would be if I wanted to start on u sub 1. if I say n is greater than or equal to 1, 1 minus 1 is 0, and actually that's supposed to be an A, and that would be if I'm starting on a 0 term or an initial term. Alrighty? The next thing that I want to give you, let me scoop my paper up a little bit, is the sum of a finite arithmetic sequence. Okay, so we're going to talk about the sum of a finite arithmetic sequence. Let's talk about the vocabulary. Remember, sum is our handy-dandy summation notation. Finite means it has a beginning and an end. And then arithmetic sequence defines the type of sequence that we're working for. So we have a formula. We talked about this in the subsequent videos because sometimes I don't have access to using that summation feature on a calculator, and so I need to be able to use a formula. And on your test, I will specify that you have to do it using the formulas. So let's do an example, but I'm going to go to a different sheet of paper. Okay, so let's say I have the sequence, and I have 1, 2, 3, 4, 5, 6. So just a really boring little sequence. I could sum all 10 terms, and so I might write the sum is equal to I is 1 to 10 of a sub n, or I could sum a piece of it. So maybe I want to sum from I equals, actually that's supposed to be an n, n equals, maybe I want to go from 5 to 9, okay? So this would be a partial sum, and this would be a full, it's really not a word, but just to show the difference between the two types. So we're going to use our handy-dandy formula, S sub n is equal to n over 2. Here's where the letters get a little bit confusing. This a sub 1 means the first term of, it's important, the summation. It's not the first term of the sequence, it's the first term of the summation. So for example, if I were setting up this formula, n is going to equal the number of terms being summed. And this is where students get a little bit frustrated with the notation because n means two different things in sequences and series. In a sequence, n represents the number's position. In a series, n represents the number of terms being summed. Okay, so this is for a series. Okay, and I would blame the ancient mathematicians for using the same variables, but they did. So we have to learn and adjust. So the same way, a sub 1 means the first term of the summation, not the first term of the sequence. A sub n is the last term of the summation. So if I look at the numbers that I have up here, so I'm summing 1 to 10 is 10 terms, right? So my n would be 10. My last term, and I'm working on this model right here, actually, so my number of terms, top minus bottom, 9 minus 5 is 4, plus 1 is 5. We always do top minus the bottom plus 1 to make sure that we include that first term. So I'm summing 5 terms. The first term of the summation would be the fifth term, 1, 2, 3, 4, 5, so this would be a 5. And then the last term of the summation would be a 10. So if I wanted to sum from n equals 5 to 9 of a sub n, and I'm going to use the sequence that I gave you, it would be my n, which was 5 over 2 times the first term, which was 5, the last term, which was 10. So this would be 15 plus 5 is 20, divided by 2 is 10. Okay, and that would be the sum of the terms from 5 to 10. Alrighty. So now let's do a nice example using real equations and such because they're way more fun. Example 3. So I want to find the 150th partial sum of the arithmetic sequence, and then I'm going to have 5, 16, 27, 38, 49. Okay, so I want to find the 150th partial sum. If we're not told, we assume that we start with the first term. So I know that a sub 1 is equal to 5. I need to know what the last term is, so I don't know that. So what I'm going to do is I'm going to write a rule. So here's a sub 1 plus n minus 1 times d. I'm going to use an explicit formula because I don't know the 149th term, so I can't use recursive. So I know that my rule is going to be, here's the first term, here's my n minus 1, and my common difference is going to be 11. 16 minus 5 is 11, 27 minus 16 is 11, so my common difference is 11. So what I'm going to do to find that term is I'm going to my sequence mode, and I'm going to put in my sequence, and I'm going to clear that guy so I don't forget, and I'm going to push 5 plus n minus 1 times 11, and then I'm not even going to put in my first term because technically it's already included in the equation. I'm going to quit, and I'm going to do second u, and I need the 150th term. The calculator's going to think, and then it's going to tell me that that 150th term is 1644. Yay, calculators. So a sub 150 is going to be 1644. Well, now if I find the 150th partial sum, s sub 150 is going to be, if you think about your index notation, this would be from n equals 1 to 150. And then here's your rule. 150 minus 1 is 149 plus 1 is 150. So it's 150 terms divided by 2 times the first term plus the last term. Now on a test, I'm going to ask you to write down the generic equation because we are going to have a series or a collection, since that's a bad choice of words in this chapter, of equations. So I want to make sure that you knew which equation to use. So I'm always going to ask you to report the base equation that you used. So then if I do this math, s sub 150 is going to equal 123, 675. Okay? So it's actually pretty easy. This is a super handy formula to know, especially when you're taking those standardized tests. Alrighty, let's do our next example. Example number 4. We only have 2 more examples to do. This one says find the sum of the first 100 positive and odd integers. Classic problem, right? So that would be 1, 3, 5, 7, 9, and I want the first 100 of those integers. So because I don't know the 100th term, I need to write a rule. So I'm going to say a sub n. By the way, your book and your calculators use those terms interchangeably. So on this one, I'm just looking at my work thinking, do I want to use a recursive formula? I don't know the 100th term. Let's just go ahead and use recursive just because we haven't done it so far. So I'm going to use a recursive formula which says it's u to the n minus 1 plus d. Well, 3 minus 1 is 2, 5 minus 3 is 2, 7 minus 5 is 2. So my u sub n is going to equal, if I move my page up, the previous term. It's going to look like this when we put it into your calculator, plus 2. Because I know the first term, my calculator is going to be able to find it. So let's go in and put, after I log back into my computer, as I put the recursive formula in, it's a little bit different. So I'm going to clear. I'm still starting on the first term, and I'm going to enter my u, second u, and then I'm going to do n minus 1. There's no subscripts on your calculator. There's my common difference 2. Now, if I'm doing recursive, I do have to tell it what the first term is. So I'm going to tell it that the first term is 1. Okay. Alrighty. And then I'm going to quit. Okay. So if I use my summation formula, it is n over 2 times a sub 1 plus a sub n. This is the term that I don't know, but I'm going to use my calculator to find it. Okay, so I'm going to find, I need to know, actually let me just set this up. So I'm summing 100, because it says find the first 100 terms divided by 2. A sub 1 was 1. This is the term we need to find, and that's going to be a sub 100. So let's use our handy-dandy grapher and find the 100th term. Okay, and when we do that, we get that it's 199. So then I'm going to put my 199 here. So this is 50 times 200, right? And so, oops, I forgot the 0. So then S sub 100 is going to equal 10,000. Okay, that's kind of cool. Alrighty, there's that number down there. All right, I have one more example, and then we are done for today. So our last example, example number 5, says find the indicated partial sum, and we're going to be given the sum from n equals 51 to 100 of 7n. Yes, I could do this in my calculator, but I'm going to ask you to do it using using the formula that we have. So I know that S sub n is equal to n divided by 2, first term, last term. Okay. So this is an arithmetic equation. It's just written in a different way when it's in summation notation. So I'm going to talk about my variables first. N is the number of terms. So if I do 100 minus 51 and then divide by, and then plus 1, 100 minus 51 is 49 plus 1 is 50. So I'm actually summing 50 terms. So S sub 50 is going to equal 50 divided by 2, and then I'm going to find my terms. I'm starting my summation at 51, so this is a unique situation. So this is going to be a sub 51, and then this is going to be a sub 100, okay? This is a very simple rule, so I'm just going to do these calculations by hand. A sub 51 is 7 times 51, which is 357, and A sub 100 is 7 times 100, which is 700. Okay, so I'm calculating the first and the last term of the summation. Then my 50th partial sum is going to equal 25 times the 357 plus the 700. And then when I do that calculation, I get 26425, and this is my 50th partial sum. Alrighty, that is it for today. I will see you soon.